Hello everyone, welcome to today's tutorial. This time we are going to learn how to visualize this flat surface in 3D space using Python. Okay, let's say you want to visualize this function, z equal to x plus 2 times y plus 5. And if you want to visualize this function, and I summarized 4 steps for you to complete this task. And the first one is we're going to prepare x and y, and then we're going to create a 2D flat surface based on x and y. So here, I think this is a unique step in order to visualize this flat surface, because if you take a look at the function, this function includes 3 different dimensions, x and y and z, right? And because z is a combination, linear combination of x and y, so when you prepare x value and y value, you need to compose them together into a 2D flat surface. And then based on this 2D flat surface, you're going to further define z, which is the second step. You're going to define the 3D function, z equal to the linear combination of x and y. After you define the data, you're going to set up the 3D coordinate system in Python. And this is the space you're going to do the visualization. Again, we're going to use this 2 specific definition to set up the 3D space. And finally, once you have the data and the 3D space, you're going to bring everything together to compose the entire function in 3D space. Okay, so let me stop share the slides here and go to the Colab. So first of all, you need to involve some libraries. You're gonna need Matplotlib, NumPy, and here you need the Matplotlib toolkits, and you're gonna need the Matplot3D. Okay, so give a little execution, and then based on our previous slides, there are 4 steps, right? So we're gonna first prepare x and y. So let's do this. So we're gonna define x. So this is small x equal to NumPy len space. So this function is really useful when you do the visualization because it can generate some data that is evenly distributed in a certain interval. So let's say my interval is -1 to 5, and I need 10 data points in this interval. So this is my x, and for y, let's say we're going to use the same function len space. And here, let's say I use 1 to 6. Oh, sorry, 0 to 6, another 10 different data points. Okay, so this is separated x and separated y. Remember, when you do this, you're going to create a list of value for x and a list of value for y. And now the second step is to compose an x and y into 2D flat surface. And this is a foundation for you to define z. Remember, z is a certain combination, linear combination of x and y, right? So we're going to do this. We're going to define big X and big Y. So this is the real data we're going to visualize in the Python. So capitalized X and capitalized Y equal to NumPy. We're going to learn this function, mesh grade. So basically, you're going to create, think about these. Mesh grade is to create a 2D flat surface based on x and y. So what you're going to do is to just bring x and y in this function. Now you have this 2D flat surface. And now, once you have that, it is easy for you to define z. And z is the linear combination of x and y, right? So it is x plus 2 times y. Remembering this time we're going to use a capitalized x and a capitalized y plus 5. Okay, so this is how we define the function, and then we're going to set up 3D space. So we're going to define fig in the first place, and that equal to plot dot figure. This is how you set up the figure and the figure size. So figure size equal to, let's say, 6 by 8, 8 by 6. And then you're gonna set up the 3D space. We're gonna use x, and that equal to your fig, and then add subplot. Remember, we have a previous lecture talking about the subplot. And inside of that, you need a projection, and that equal to quotation 3D. So this is how you set up 3D space for your visualization. Okay, once you have that, we're going to bring everything together. And this time we're going to use x.plot underline wireframe, because that is how you want to visualize the flat surface. And then you're going to give that function your x, capitalized X, capitalized Y, and capitalized Z, and plt.show. So this is all you need. Let's try that. Okay, now you can see that in this 3D space, you have a function, which is x plus 2y plus 5. And okay, so I hope you enjoyed today's video, and I will see you next time.